Some of the smartest people in the world spent years figuring out how to hijack your brain and make you unable to stop scrolling. And, well, they succeeded. In February 2013, a Google employee named Tristan Harris wrote a presentation and shared it with 10 colleagues, 141 slides arguing that the design decisions being made inside Google and across Silicon Valley more broadly were systematically exploiting human psychology. He called it a call to minimize distraction and respect users' attention. That presentation was never meant to leave that small group, but within days, it had spread to tens of thousands of Google employees. Harris described a system that had been deliberately constructed to capture human attention and hold it, making you the product and not the app itself. Nothing fundamental changed after Harris left. The system he described kept running, and the people building it kept getting better at it. They had learned how to exploit the most vulnerable parts of human psychology, with more data about human behavior than any government or intelligence agency had ever collected. All of it to keep you scrolling. In 1998, a researcher at Stanford named B.J. Fogg founded something he called the Persuasive Technology Lab. The premise was that computers could be designed to change people's attitudes and behaviors, and understanding how to do that systematically was worth studying. Fogg wasn't thinking about social media. It barely existed yet. He was interested in the basic mechanics of influence and how those principles could be embedded into technology. Fogg's students went on to build some of the most widely used products in the world. Mike Krieger, who co-founded Instagram, took Fogg's class. The course, originally called Creating Engaging Facebook Apps, taught students to apply behavioral psychology to product design, how to structure rewards and deploy triggers to keep users returning. Instagram launched in October 2010 and reached 1 million users in 2 months. Nair Eyal, who attended events at Fogg's lab, published a book in 2014 called Hooked: How to Build Habit-Forming Products, which became the industry standard. The hook model it described, a loop of trigger, action, variable reward, and investment, was adopted by product teams at companies including Pinterest and Slack. It was, in essence, a manual for applying the same variable reward schedules that Natasha Dow-Schull had documented in casino slot machines to consumer software. The variable reward piece is worth dwelling on. B.F. Skinner's research in the mid-20th century established that unpredictable rewards produce stronger behavioral responses than predictable ones, a phenomenon called variable ratio reinforcement. Slot machines were built around this principle, and what Fogg's lab and Eyal's model did was translate it into a design language that product teams could implement at scale across platforms used by billions of people, without most of those people having any idea the mechanism existed. Tristan Harris studied in that same environment before going to Google. What he eventually concluded from the inside was that the tools his colleagues had learned to build were being deployed without anything resembling ethical constraint. The metrics the industry used to measure success made the manipulation invisible, and that invisibility was built into the model. None of those numbers, engagement, session length, or daily active users, captured what was being extracted in exchange. The infinite scroll was invented in 2006 by a designer named Asa Raskin. He built it in about 2 hours. The idea was simple. Instead of clicking to load the next page, content would appear automatically as the user scrolled down, with no natural stopping point and no moment where the user had to actively choose to continue. Raskin thought it would make websites easier to use. Years later, he estimated that the feature now costs humanity roughly 200,000 hours of human attention every day. He has since become one of the loudest critics of the design patterns he helped create, and co-founded the Center for Humane Technology, alongside Tristan Harris. What Infinite Scroll does neurologically is remove the moment of decision. Every natural stopping point in an interface is an opportunity for the prefrontal cortex to reassert control, to ask consciously whether this is still worth doing. Without those moments, the wanting system stays engaged because there's always something coming, and the deliberate part of the brain never gets a foothold. Netflix introduced autoplay in 2012 on the same principle. The 10-second countdown before the next episode begins feels like a choice, but the default is inaction, and inaction produces exactly the outcome the platform wants: Sean Parker, one of Facebook's founding presidents, described the underlying logic in a 2017 interview with striking candor. He said the goal from the beginning was to consume as much of users' time and conscious attention as possible, and that the like button was designed to give users a small dopamine hit, enough to keep them uploading content and coming back for more. What Parker described is a deliberate exploitation of the same wanting system that Kent Berridge spent his career mapping. The like button was engineered to produce anticipation. The satisfaction, when it comes at all, is almost beside the point. The dopamine response fires when the notification arrives. The brain has been conditioned to treat it as a signal that something might be coming, regardless of whether anything meaningful actually does. And a system built around that conditioning, deployed at scale across billions of users, produces outcomes that no individual user would choose if they could see the mechanism clearly. Variable rewards activate the dopamine system more reliably than consistent ones, and removing friction lowers the threshold enough that the behavior starts almost automatically. And social validation, likes, comments, or shares, taps into circuits that evolved for navigating small group dynamics, now running in an environment where the feedback arrives instantly. And at a scale, those circuits were never designed to process. Each of these mechanisms was understood by behavioral scientists long before social media existed. What changed is that a generation of product designers learned to combine them deliberately and measure their effectiveness in real time. In 2017, a researcher named Jean Twenge at San Diego State University published a paper in the journal Clinical Psychological Science that caused considerable discomfort in Silicon Valley. She had been tracking mental health data for American adolescents since the early 2010s and noticed something that didn't fit the existing trend lines. Around 2012, rates of depression and anxiety among teenagers began rising sharply, particularly among girls. The timing coincided almost exactly with the widespread adoption of smartphones and social media. Twenge was careful not to claim causation from correlation alone, and the debate around her findings has been ongoing in the research community. But the pattern she documented was hard to dismiss, and it prompted a wave of follow-up research that has since produced a more complicated picture. What that research has started to map goes beyond the psychological effects of social media use. The neurological ones are proving just as significant. A 2023 study published in JAMA Pediatrics, led by Maria Mazza at the University of North Carolina, followed 169 adolescents over 3 years and found that habitual checking behavior on social media was associated with measurable changes in brain development, specifically in regions involved in reward processing and impulse control. The brains of frequent checkers showed heightened sensitivity to social rewards over time, a pattern consistent with what addiction researchers see in other forms of compulsive behavior. The same neural adaptation that Mazza's team documented in developing brains happens more slowly in adult brains as well. Anna Lemke at Stanford has documented how chronic exposure to high-stimulation inputs shifts the brain's baseline. The dopamine system recalibrates downward, requiring more stimulation to produce the same response. What starts as a habit gradually becomes the condition under which ordinary experience is evaluated. Gloria Mark's research at UC Irvine found that the average duration of focused attention on a screen dropped from about 2.5 minutes in 2004 to around 47 seconds by the early 2020s, a measurable neurological consequence of an environment engineered to fragment attention. A distracted mind checks more often, generating more data. And more data means better targeting, which means more engagement. The business model was built around the fragmentation of attention. The distraction was never incidental. It was the product. Understanding how a system works doesn't necessarily give you the power to leave it, but it changes your relationship to it in ways that willpower alone can't. Most people aren't going to stop using the internet, and the argument that they should is largely beside the point. What changes with understanding is that the mechanism stops operating invisibly. Tristan Harris has described this as the difference between a user and a participant, whether the system is operating on you or with your awareness. The distinction sounds philosophical, but it has practical consequences. BJ Fogg has said in interviews that the most effective defense against persuasive technology isn't willpower or digital detox. It's understanding how it works. Once you can see the trigger and the reward structure underneath it, the spell breaks, because the mechanisms only work invisibly. This is consistent with what neuroscientists call metacognition, the capacity to observe your own mental processes as they're happening. Research by psychologist Ethan Kross at the University of Michigan has shown that metacognitive distance, the ability to observe an impulse without immediately acting on it, significantly reduces the behavioral pull of that impulse. The craving doesn't disappear, but the automaticity loosens enough that a gap opens between the trigger and the response. What that looks like in practice is less dramatic than most advice suggests. It doesn't require deleting apps or retreating from technology entirely. It requires developing the habit of noticing, recognizing the moment when the wanting system has been activated by a designed trigger and deciding from that position rather than from inside the pull. A notification arrives and the impulse to check fires. Seeing that impulse as the product of a system engineered to produce it changes the relationship to it in a way that's difficult to fully describe until it's been experienced. The companies that built these systems understand something important. The mechanism is most powerful when it's invisible, which is why the most consequential thing Tristan Harris did was writing 141 slides that made the invisible visible and sending them to 10 people. Asa Raskin built the infinite scroll in 2 hours and spent years afterward trying to undo what that afternoon produced. He has testified before lawmakers and co-founded organizations dedicated to reversing the harms. The feature is still everywhere, and the attention it was designed to capture is still being captured at the same scale, now refined by a decade of additional data about exactly which variations produce the strongest response. There's something worth sitting with in that gap, between the person who understands what's happening and the system that keeps happening anyway. Raskin understands it better than almost anyone. Harris does too, and Fogg in his own way helped build it. And the platforms keep running. What the neuroscience suggests is that this isn't primarily a policy problem or a technology problem. It's a problem of visibility. The system was built to be invisible, and for most of the people it runs on, it still is. And seeing the trigger for what it is rather than being pulled by it is the only leverage point that doesn't require waiting for someone else to act first. Tristan Harris wrote 141 slides in 2013. They went to 10 people, spread to tens of thousands inside Google, and eventually reached 100 million through a documentary. And the regulatory conversations they helped spark are still unresolved. The mechanism he described in those slides is still running, but the number of people who can see it is larger than it was. It's not a solution, but it might be where one begins to look for one.